Hi students, welcome to Year 9 Science and our amazing Earth, our second unit in science this year. This is video number 6 and we're going to start to apply some of the learnings that we've already gained about plate tectonic theory. What you need to do in this particular video and the subsequent activities is to justify the use of the theory of plate tectonics to explain continental drift and seafloor spreading. So a couple of phenomena that we've now looked at, and is there a way that we can directly link our understanding of plate tectonics to both of these two phenomena? Well, the first thing that we need to do is to get a bit of a sense of the difference between the two main types of crust. There is oceanic crust and there is continental crust. What's a useful thing for you to do is to actually tabulate differences between two things that you're looking for comparisons. It makes it very easy to then memorize the key differences and also for you to be able to visualize those very quickly. Now, oceanic crust is important. It's found below sea level. It's the sort of stuff that we've talked about forming at mid-ocean ridges. It tends to be relatively thin. In fact, when we compare oceanic and continental crust, we find continental crust is way thicker than oceanic crust. But the thing about oceanic crust is it's very dense, and its density is a really important characteristic in comparison to continental crust, because we're actually going to start looking at where two different types of crust meet, what actually happens to them at those sort of boundaries between the plates. It's often dark. If you look at the sample here of a basalt, this is a good way of thinking about oceanic crust. The basalt itself is a very dark rock, and it's made up of a number of different types of minerals. And usually the oceanic crust has high proportions of iron and magnesium minerals present. And so the basalts are your typical sort of types of rock if you want to think about something to focus your attention on for oceanic crust. On the other hand, continental crust tends to be found above sea level. It's much thicker, as I mentioned before, and it's less dense. And that, again, is something that we're going to draw on a little bit later on. It's as a rock lighter, generally speaking, due to the higher proportions of silicon and aluminium. And if you look at this sample of granite that I've popped on the slide here, you can see just looking at the difference between a granite and a basalt gives you, at least with no understanding of these two different rocks, that something interesting is going on here. Something is different about these two different types of rocks just because their appearance is so different. There's certainly some pink material that dominates the granite that's not present, or certainly doesn't seem to be present in the basalt. And even though that you can see, obviously, the basalt's dominated by darker minerals, also the granite has some darker minerals in it as well. So rock types is hopefully something you've had a little bit of a look at previously, and not something that we want to go into in a lot of detail in this unit. What we do want to do is just make sure that we've got a difference in our heads of oceanic crust, which is very dense, very thin, and very dark, and continental crust, which is less dense, but much thicker and much lighter in appearance. Now, the important thing about trying to use plate tectonics with continental drift is that we've said that there was evidence that supports the idea of continental drift, and then we've talked about plate tectonics as the mechanism for continental drift. And in actual fact, that's still not quite the full story, and we still need some component of this mechanism to actually drive the plates on their journeys, and we'll look at that in another video soon. But what we can do is at least try and understand that the fact that the continents do seem to be sitting on the middle or towards the edge of these plates, that we can start to get a little bit of an idea about what's going on. As I've mentioned in a previous video, the most important things is the continents can move not just relative to one another, but at different rates and in different directions. And that's the most important thing that you need to remember about this, because some of the geological formations that we've attributed to plate tectonics are a consequence of this differential rate of motion for the different plates. One interesting example is India, which was once part of Gondwana, and you remember Gondwana was the southern supercontinent. So it was originally part of the group that included South America and Africa, Australia and Antarctica, and yet now it is very much a part of Asia. What we have here is a collision between two types of continental crust. So you can see what's happening is as the Asian plate hasn't kind of moved too much, but the Indian plate has moved a great deal towards the Asian plate. What we've had is a collision between continental crust and continental crust. Now, if there are differences in the density, then one of these substances will basically float or sit above the other. Now, we do see some of that happening when we look at the interaction between continental crust and oceanic crust. But where continental crust meets continental crust, neither of them are more or less dense, or certainly not to any great degree, and so therefore all they do is just push into each other. And effectively, as they get as the pressure builds, you can actually see that the material starts to buckle and fold over the top of itself. And what this does is this creates massive mountain ranges. And so the mountain ranges that are formed are a result of this collision between two plates, both of whom consist of continental crust. What this has done is it's built the beautiful and incredibly high Himalayan mountain range. And of course that includes Mount Everest, K2, some of the tallest mountains that we have on planet Earth. And that is a result of this idea of India as a plate moving very, very quickly relative to the other plates around it towards Asia, and the fact that it's continuing to buckle itself into Asia, meaning we're going to lose some landmass, but we're going to continue to build these mountain ranges. Likewise, we can also see what's happening in terms of seafloor spreading by looking at other examples of where this is starting to occur. Seafloor spreading tends to, or at least appears to start at what we call a rift valley. Rift valleys form between two types of continental crust, but they form where the plates are actually moving apart from one another, not towards one another, as we saw in the previous example. In this example, two plates start to pull apart from one another, and you can see this happening to a certain extent where the Arabian plate is slightly moving away from the African plate. And you get this formation of a sea in between them, the Red Sea. Now this appears to be growing. There seems to be an understanding that as these two plates continue to move further and further apart, that space in between them will continue to be filled with water. So obviously a sea is a small body of water in comparison to an ocean, but over time that could continue to have these split further and further apart. This valley would continue to open until we had a point where perhaps material that was coming from underneath that's pushing these two plates apart from one another starts to create oceanic crust, starts to create a new ocean. Now, the rate at which this is happening doesn't suggest this is going to be something we're going to see, but certainly, and we'll look at some of the technology that we have started to develop and apply to our understanding of plate tectonics to show that these sorts of things are occurring. We can detect the levels, the direction, and the rate of plate movements respective to one another, and to see how some of these geological formations that we have already on Earth can be explained by our plate tectonics model. Now, this is a very quick overview, and what we really need to do is to start to examine these boundaries between plates in a lot more detail. And when we do, we find some really interesting geological formations that are a result of different types of plate boundaries. But we will save that for another video. Thanks for watching.